Hello and welcome to section 10.4. Today we're going to continue on with quadratic relations and conic sections, and specifically we're going to look at how ellipses tie into that. To begin with, let's look at what an ellipse is. Now, by definition, an ellipse is a set of all points such that the sum of the distances between a certain point P and two very distinct fixed points, which we call the foci, is a constant. So in other words, if I have an ellipse, kind of like what you see here, maybe a little bit better, if you can draw it better, and you have some point, and we're going to call that point P on the ellipse itself, we have 2 points inside of the ellipse, and those are going to be connected to point P. And we're going to call this distance 1, distance 2, and each of these points inside of the ellipse are what we call the foci. Now, if we take our distance 1 and we add it to our second distance, we end up with some constant. So again, we have a point on the outside of or somewhere on the ellipse itself. We have 2 points on the inside, which are called the foci points. And if you add the distance between that point P and the 2 distances to the foci, then we're going to end up with a constant. And any line that goes through the foci is going to intersect our ellipse at what we call a vertex, or because there's 2 of them, it's going to be vertices. So if we were to come in here and draw a line, it's this point of intersection here and here is what we call the vertex for one of them, or vertices for the plural. Now this line here that we just used to connect the 2 vertices is called the major axis, and it has a midpoint here in the center. Now if I take and draw a line perpendicular to the major axis and I go through that center, as I'm doing right here in pink, this is what we call a covertice, and it's going to intersect our ellipse at 2 points. We're going to intersect the ellipse at the 2 covertices, and the line itself is called the minor axis. Now notice that the minor axis is on what you may consider the short side of the ellipse, while the major axis is on the long side of the ellipse. So kind of to sum things up, we have 2 different ways that we can draw an ellipse. We either have a horizontal ellipse, and by horizontal we mean that the major axis lies in the horizontal direction. So if we're looking at something like that, we see that we have our major axis right here with our vertices at the ends. We have our minor axis on the short side with covertices. We have our focus on the inside here. We have our center point. And with this, it gives us the standard form of the equation of an ellipse. So this equation right here, x squared divided by a squared plus y squared divided by b squared equals 1. Now, if you notice, the a squared, that kind of corresponds to the major axis. And you can see that because that's part of your vertex. If you take the square root of this number down here, that's going to give you the coordinates of your vertex or vertice points. Likewise, the b value is going to correspond to your covertices just by taking the square root of it, and then you're going to have a positive and a negative in this case, only because our ellipse is centered at 0, 0. And likewise, if we have an ellipse that runs in the vertical direction with the major axis, we have a similar situation. Here's our major axis. We have vertice points right here and here. We have a covertice on the minor axis, and it's going to run horizontally this time. And we're given this equation right here, where we're going x squared divided by b squared plus y squared divided by a squared equals 1. So regardless of the direction we're going, we are always going to have an equation set equal to 1, and if it's not set equal to 1, we're going to make it set equal to 1. So to kind of sum up everything from those 2 pictures, the characteristics of an ellipse, and I have to specify again and really emphasize this is only when we're centered at the origin. When we go to move off the origin, our equation is going to change just a little bit. Okay, so if we have a horizontal major axis, we're going to have x squared divided by a squared plus y squared divided by b squared equals 1. That means our vertice points are going to be plus or minus a and 0, and our co-vertices are going to be 0 and then plus or minus b. Likewise, if I have a vertical major axis, or my longer side of the ellipse is on the going in the vertical direction, then we have x squared divided by b squared plus y squared divided by a squared equals 1. My vertice points are going to be at 0 plus or minus a, and my co-vertices are going to be at plus or minus b and 0. Now when we go to find the foci of an ellipse, these are going to be on the major axis, and we're going to say that they are quote-unquote C units from the center. Now if there's C units from the center, that means that we can calculate these points, and we come up with the focus points by going c squared equals a squared minus b squared. And we will do an example with this. So example 1 says to graph the equation 4x squared plus 25y squared equals 100. Then we're going to identify the vertices, the co-vertices, and the foci of the ellipse. It's actually going to be easier to identify those things first, and then based on those we can graph our equation. So the first thing we want to do is we want to make sure that our equation is set to standard form. And the first thing I notice is that we have an x squared term plus a y squared term equals 100. Well, we can't have it equal 100. We need to make this equal 1 because that's the standard form for an ellipse. So the first thing I'm going to do is I'm going to take that 4x squared plus 25y squared equals 100, and we're going to divide everything by 100. And by doing that, we're going to make this term here turn into 1. So 4 divided by 100 is going to give us 1/25. So that means I can rewrite this then as x squared divided by 25 plus 25 divided by 100 is 1/4. So we have y squared divided by 4 equals 1. So now I have an equation written in standard form, and I notice that the number below the x squared value is larger than the number below the y squared value, so that tells me that I'm going to have a horizontal ellipse, and because I have a horizontal ellipse, now I can identify my a value, and that's just the square root of 25, which is going to give me 5. And my b value is going to be the number below the y squared value, which is the square root of 4, or 2. So based on that, I can come up with vertice points at, I have 5, 0, and a -5, 0. I'm going to have co-vertice points at the point 0, 2, and 0, -2. And then I also have to find my foci. So for our foci, we know that the foci is going to lie on the major axis, and it's going to be the C units from the center. So we're going to have to use that relationship for C that says, C squared is equal to A squared minus B squared, which in this case is 25 minus 4, which is 21. So if I want to find my actual C value, then I end up with plus or minus the square root of 21. So that tells me then the coordinates of my foci are going to be at the square root of 21 and 0 and a negative square root of 21 and 0. So now by putting together all of this information, I end up with a graph that looks like this. I have my vertex here at negative 5, 0, another vertex at 5, 0. Then I have a co-vertex at 0, 2 and 0, negative 2. I have my two foci points, and I'm then able to go in and draw my ellipse. And now we have example 2, where it says to write the equation of ellipse that's centered at 0, 0 and has the given characteristics. So for part A, we know that the vertex is at 0, 5, and the co-vertex is at 4, 0. Now because my vertex is at 0, 5, this lies on the y-axis. So even if you were to just kind of sketch something like this, you have 0, 5 up here, 0, negative 5, 4, 0, and 0, 4, or I'm sorry, negative 4, 0, and 4, 0. So you're going to end up with an ellipse that looks like this. And what this tells you is that the value below your x squared value is going to be less than the value below your y squared value, because this is going to be a vertical ellipse. So based on that information, we're going to have an x squared divided by a term plus a y squared divided by a term equals 1. Now remember, because this is the smaller value, since it's a vertical ellipse, I get that from my co-vertice points, which is right here. And this right here is really the square root of what goes below here. So I'm going to take 4 and square it, and that's going to give me 16. Likewise, the value that goes below y squared is going to come from the vertex, and I'm going to square this value, so then I end up with 25 here. So as you can see then, I end up with x squared divided by 16 plus y squared divided by 25 equals 1. And that's the equation of my ellipse. Now, for part B, we're given that we have a vertex at negative 6, 0 and a focus point at 3, 0. So because my focus point is going to lie on the x-axis along with my vertex, that tells me I have a horizontal major axis and that my value below the x squared value is going to be greater than the value below the y squared value. So because I'm given the vertex, I actually know my a value. I have to go and find my b value. The only way we can do that is by using the relationship that c squared equals a squared minus b squared. We know that c is going to be 3. So we're given that 9 is equal to, we've already identified that a is negative 6. If I square negative 6, we end up with 36. And then we're going to subtract our b squared value. So solving for b, we end up with the square root of 27. So I know that b is the square root of 27. We know that a is equal to 6. So based on that now, my equation then is going to be x squared divided by my a squared, which is 6 squared, or 36, plus y squared divided by my b squared value, or the square root of 27 squared, which is 27, and this will again equal 1. And it's at this point in time that I am done. So if you have any questions, please make sure to write them down, and I will go over those with you in class tomorrow, and I hope you guys have a great day.